So I have drawn this picture to give us kind of like an intuitive impression on how to reverse a linked list using iteration. So there are three nodes, 1, 2, and 3, and the 3 is pointing to none because it is the last node. And I have kept the location part of the node empty because I kind of think that it doesn't really matter the exact numbers. But we should always keep in mind that the location part of the node is always there in linked list, and it is always pointing to the location in the memory of the next node. So here's how we're going to do it. We're going to make these nodes into three parts. The previous, the current, and the next. And to do it is just to make the current node point to the previous and to do it again and again. But we need to keep in mind two things. First, next node should be stored before we doing the pointing thing. Because when the current node is pointing to the previous node, it lost the information of the next node. So we should keep it before we do the pointing. And the next thing to remember is that we should make the current node and the previous one into a new previous one and store it there before we do the next iteration. So now let's try to do it. I have already coded out a little bit, so the previous should be none, and it is a new thing that we have to create on our own, and then we need to decide what is the ending case in this loop. So to decide, let's try to write it out what we're going to do. So the first thing in the loop is that we need to store the next nodes. And the second thing is that we need to let's take a picture. We need to make the current node point to the previous one. And the third thing is the previous one is stored, a new previous. And the last thing is that we need to make the current node go to the next part. So in this case that I have pointed out, we have seen that at the end we're going to return the previous node because the previous node is the thing that has really left for us, and while doing it, we have to have the head because then there's nothing to it can point to, and at the same time the next is none. So when we're doing the iteration, we need to make sure that the head really exists. Now we store the next node. We make the current node point to the previous one. And we store the new pref. And then we make the head go to the next part. And we return the proof. And again, this is the LEET code, and we always need to examine the extreme case. And in this case, it is that when there isn't a head. When there isn't a head, it means head is none, and we need to return a void string, an empty string. So this is it. Let's try to take a look at the picture again. When the one is coming into this this loop because one is not head, and and the next is 2 3, and head dot next is previous, so it's pointing to previous, and the previous becomes the new head, and the new previous becomes the head, and head goes to here, and all those procedure goes again, and when there is the 3, which is the last head, the last iteration that this loop is doing, here the next becomes this, and at the end all current and previous becomes the new node, becomes the new linked list. So let's try to run it. It's accepted, and the time complexity is O(n) because it goes from the first to the last node.